Okay, so it's 4:05 European time. So welcome to the second technical session of FRINGE 2021 workshop. So here we are discussing within three communities, ice and snow, land cover and vegetation, and volcanoes. So these technical discussions, this is the online version of the roundtable discussions at Esrin or elsewhere we would have in the room that the session took place. So the purpose of this discussion is to give an open floor to anybody in the community to speak up and raise important issues. And the reason why we are doing this is that ESA is gathering recommendations not only for ESA but also for the community. So this is the session where you can propose that, campaigns, studies, observation scenarios, future missions, these kind of things. And the chairpersons are going to present some seed questions and a short summary from these three domains. There we have nominally 20 minutes per theme. So we are trying to keep the time, but we can go a little bit longer if strictly necessary. And the next thing that happens after this is that based on these discussions that take place now, the chairpersons will prepare a short summary that will be presented in the summary session on Friday. So I just checked the time. It's on Friday, that's the last thing of the workshop at 3:30 European time. So yes, we are ready to go. So Ice and Snow, you can take the floor. Oh, excuse me, one last thing. So yeah, if the participants, you have a question, you can put it in the Q&A panel on WebEx, and also if you can raise your hand, and then you will be given the floor to speak. So that should be the procedure. All right. So Thomas, is it you or?
I think it's Magdalena who is the boss of the slides.
Yes.
Actually, it's Ulla.
Ulla.
Next slide.
Just next slide, please. Okay. And also next slide. So we had 2 snow sessions and ice sessions this morning. And additionally, we had also a poster session this afternoon. Overall, we had 10 oral presentations and 13 poster presented. And in the next couple of minutes, I will present you an overview on the parameters which we were touching as the baseline for the seed questions and the discussion afterwards. So overall, we were touching 6 parameters of the land cryosphere. Ice velocity was covered by 10 presentations or posters. The highlights were that in the last years, since the last FRINGE and Living Planet conference, we solved the problem on Sentinel-1 TOPS INSAR velocity over moving ice, and the first examples of basins and Greenland-wide ice sheet velocity map was shown. This was also applied to Antarctica with other sensors. So phase information combined with offset tracking was shown derived from different SAR sensors to generate a high quality Antarctic ice sheet velocity map. And additionally, an outlook for future sensors in the Earth Explorer program was given. We were also addressing single and multi-sensor ice velocity retrieval using SAR and in combination with optical sensors for mountain glaciers. And in the poster sessions, also the preparation for ice velocity from current ALB and SAR systems was presented, what is ongoing currently in Antarctica especially, and also plans for future ALB and sensors have been presented. Regarding grounding lines, there were overall 3 presentations given. One were dealing with the delineation of the grounding line applying artificial intelligence, so deep learning, which is applied on interferometric data. And also an automatic procedure for generating time series of grounding lines for Antarctica from different SAR sensors, starting with ERS, NVSAT formerly, but going up to TerraCX and Sentinel were presented. Ice shelf crack propagation and detection of early signs for warning have been presented using a kind of prototype method for automatic delineation using the continuous monitoring of the Antarctic margins using Sentinel-1 INSA data. Regarding surface elevation change and mass balance, we had overall 3 presentations, and this one was quite major on the to generate a global inventory of the glacier surface elevation change derived from satellite-based digital elevation models, and this is then converted to a geodetic mass balance product. And also an application to look for the mass changes derived, or ice thickness data derived from ice velocity using the assimilation of ice velocity into models. Related to permafrost, overall, there were 4 presentations handling with SAR interferometry primarily. This is on the time series on the thaw subsidence and frost heave, and also coupling with the model to interpret the data. There was the interferometric mapping of key indicators related to easy permafrost in the Arctic, and the kind of permafrost degradation monitoring in mountain areas in Himalaya using SAR interferometry, primarily from Sentinel-1. Related to the seasonal snow, there were 2 presentations on the snow water equivalent. One was dealing with the feasibility of a multi-frequency approach, applying the sphere retrieval using SAR interferometry from TerraCX, C-band and L-band data, and also to test the Polinsar approach for snow depth and snow water equivalent retrieval using tandem X data in mountain regions. And with this short introduction, I will just switch on to the seed questions on this ice and snow. Ulla, can you just go on? Next slide, please. Okay, thanks. And the first question, what we are asking you, based on this very quick summary and the presentation from today, are there any gaps in the observation of key ice sheet, glaciers, snow and permafrost parameters? And can we close these gaps by optimizing the acquisition strategy of the current missions? Are there any further data or repeat pass data needed in order to fill these gaps? So I open the floor now for this, and
if there's no question, maybe I can provide some discussion on the gap. So I think we've seen today that phase information is getting more and more useful for mapping ice velocity. So there is the question in terms of gaps in observation about having ascending, descending passes that would cover ice masses. So we can actually retrieve 2D field, 2D displacement. Yeah, it has been shown that in Greenland and parts, there is a region where it's doable, but not necessarily over all Greenland. And the same question could be raised for Antarctica, where I think there is only a few places where we have enough diversity to use the phase really with ascending, descending passes. So we could have a recommendation concerning this kind of gap of having different kind of line of sight. So ascending, descending passes for doing 2D velocity map using the phase in Antarctica and Greenland mainly, but maybe this could also be useful for a mountainous area.
If there is no comment directly now, I can also just make a general comment for the permafrost part. Something that is a bit specific for permafrost application is, which is not exactly the same for the other ice application, is that strictly speaking, we cannot really document permafrost based on INSAR, since permafrost is a subground phenomena, and it's a thermal property. So the main challenge scientifically is that it's not directly related to the problem related to the missions, but scientifically it's how to relate what we measure with INSAR, so movement, to key parameters that are important in terms of climate change indicators. And that is the coupling with modeling or with other remote sensing products at a large scale. That is the research challenge now, basically. And I believe for that, one thing that will be beneficial in future mission is really having more overlap of different frequency missions. So the L band will be Rose L, and NISAR will be a real value to have some to measure different kind of properties, because larger wavelengths are of course provide a better coherence and less challenge on wet surfaces, by example. But NISAR is not covering the Arctic, so for that result is really will be quite a game changer.
Are there comments from the community? Maybe we just go step by step. Any gaps for ice sheets? What you want to mention here? So these are gaps regarding the parameter, but also gaps related to data acquisitions, which we could forward to Copernicus and other space agencies. So something what is definitely needed, I would say, is a continuous coverage of the margins of Antarctica with 6 days by Sentinel-1 A and B. So this is definitely needed in order to calculate mass fluxes and as a contribution to the sea level rise. Currently, we have quite a good coverage, but still a couple of outlet glaciers and parts of the coastline are missing, and these gaps should be closed to close this gap. Regarding the Arctic and Sentinel-1, I suggest to adapt the acquisition planning, at least for the winter campaigns of Sentinel-1, to have a complete coverage of crossing orbits. And this could be also extended to the Arctic ice cap, so Russian ice cap and Svalbard, to include these parts too for ice velocity and finally ice discharge estimations. So this is related to the current Sentinel-1 acquisition planning.
And Thomas, in the chat, there is also a comment from Ludwin Libert.
Okay, yes, Ludwin, can you just ask the question? Or?
It's written there.
Okay.
The comment.
So Ludwin Libert mentioned that over Antarctica, Sentinel-1 covers most of the margins with 12 days repeat, and this limits the applicability of SAR interferometry of fast flowing areas and having 6 days repeat over all of the margins, that would improve the applicability, of course. Okay, thank you, Ludwig.
Yeah, so I think it's a good question for Antarctica. It would probably make sense to move to 6 days if it's if it's doable, because there would be it would be very beneficial for ground line mapping, also for region where there is a lot of decorrelation, like some parts of East Antarctica, where the 6 days would prove beneficial, I guess. And in the same way, what you mentioned for Greenland, having ascending descending tracks, I think it would prove beneficial in Antarctica as well. Maybe not all the time, but campaigns during certain time where crossing orbits are required, so phase information can be used in more used than it is right now.
If I may add, if it's only possible on campaign basis, so please recommend when the campaign should take place, because currently the Sentinel-1 constellation is fully utilized and Antarctica is not small, so it will probably not be possible for everywhere all the time.
So my guess, but this is also open to discussion, is that if it's only based on campaign, it should be during the Antarctic polar nights, so when there's less changes on the surface, I think, but then maybe other people have different recommendation.
Okay, if there are no further recommendations, we go on with the second question. Which advancements can be expected from future approved missions, and which open questions call for new mission concepts and techniques? So this addresses the upcoming missions like, of course, Roselle, but also in very near future, NISAR. And the new mission concepts would be the Earth Explorer candidates, for example, which are currently in phase A, for example, Harmony mission.
Yeah, and I would add to that question that, and what kind of R&D support activities should be started, okay. Campaigns, studies, etc.
If I may, I think talking about future missions that are in development, one application would be to retrieve the 3D displacement of ground object. So it can be ice, but it could be something else. And then to prove that this would work, or to test some algorithm, it may be some campaign using Sentinel-1, for example, or the sensor could be made where actually this concept could be tested on real data.
Of course, in preparation for Harmony, bistatic measurements are definitely needed. So that's something what is quite unknown by now, and that's something what we need to investigate.
So what's available currently from TandemX is not enough?
It's not enough because we are looking here for C-band, and then of course the parallax is much bigger. So just to keep one eye on the time, I think we have to go on for the third question. What is the preferred Sentinel-1 orbit configuration for 3 satellites, A, B, and C, in orbit for optimizing the observation of essential snow, glacier, and ice sheet parameters? Here I can give you some background information. There are actually 4 options of orbit configurations in discussion. So 2 of them are maximizing the coverage, which means that we are shifting Sentinel-1 ABC into a 4 days repeat orbit, keeping overall the 12 days with the 3 satellites. Another idea, what was proposed, is a kind of single pass interferometric configuration, applying pursuited monostatic acquisitions between A and C, which would mean that A and B would stay in this 6 days orbit configuration that it's currently the case. And we would put C just a few minutes afterwards, A, so to have a kind of pursuitic monostatic acquisition with a very small or no temporal decorrelation. And the third proposal is to operate A and C very similar to ERS tandem with 1-day repeat pass. This would have an improvement of coherence and also a better applicability for fast-moving glaciers using siren interferometry. So there are also other applications for glaciers, of course, and especially also for permafrost. And I hope to get here some feedback because this is currently in discussion and proposed to Copernicus. And I think there we should speak as one voice as a community. So please provide here some feedback on that.
Yes, Thomas, you are correct that a single voice from the community would be good. Maybe you have not heard the news. So the news is unfortunately not fantastic in the sense that operating 3 Sentinels instead of 2, 3 Sentinel-1s instead of 2 is a very significant increase in the constellation operations and the ground segment. And currently, there is no Copernicus budget for operating 3 of them at the same time. So unless the European Commission finds new funding from the Copernicus program, the third unit will be in hot storage in orbit, ready to take over if necessary, but it will not be available even on a campaign basis. So this is the current situation, but of course, lobbying can happen and things can change.
Yes, so hopefully I heard this bad news already, but we still have to get some backup from the community in order to be prepared on our opinion what is needed if we have the opportunity for getting a third mission.
So if I can jump in, so let's do still a recommendation based on what you explained, Thomas, even if it doesn't fly. I mean, we can always propose. So between the 4 scenarios you propose, I think, in my opinion, the best one would be the 1-day repeat pass as it was done for ERS tandem, just because doing this, we would cover the kind of motion or displacement that we cannot cover right now. So that would correspond to fast displacement. And it would actually, so we were talking about gaps in observation. I think having 1 day would fill some of these gaps by looking at the very fast change on the ground, and we would keep coherence for these fast changes. So it's just my own opinion, but I would favor the 1-day repeat pass between the different scenarios.
Yeah, so there was another vote for 1-day repeat pass, pointing out it's a huge improvement. So from Ramon Hansen, there was a comment what is needed to convince EC to operate 3 Sentinel-1s. It would be a killer application. I completely agree that it would be a big game changer. I think the only thing what is needed is money and more budget, but okay, we will see what's possible and hope for the time. I think also from the permafrost, it would be very nice to get some feedback on this.
Yeah, I mean, if it would be good if other people from the permafrost community in there can take a voice, because there are other people much more experienced than me. But what I can say that for sure a shorter temporal baseline or better repeat pass will improve the time series and allow for a monitoring of faster also ground movement. So absolutely agree that 3 at the same time would be valuable also for permafrost application.
There's a question from the audience from Quentin Claude. You can enter the discussion, Quentin. Thank you.
Hi, no, I was just commenting on the fact that also for me, I think the one-day repeat pass using Sentinel 1A and C would be very beneficial in order to get velocity. That's just a comment I wanted to share. Thank you.
From the Glacier community, are there any comments? I think that it would they would also support the one-day repeat because it has a big impact on the coherence and of course on the velocity magnitude what we can observe with this. So I noted down that from the ice community and also permafrost community, a kind of ERS standard mission with one-day repeat pass would be highly needed. And at least for a certain period, this should be operating like this if possible. Then the last seed question is how should Sentinel-1 and the upcoming or already operating ALP and SAR missions operate? And how should we coordinate this to enhance and complement observation and ice and snow? And the permafrost parameters in polar and mountain regions. I think there are a couple of opportunities, keeping in mind that Sentinel-1 is operating very closely with ROSE-L. So there is a proposal that they fly very close in the same orbital plane so that we would have dual frequency acquisitions within a few minutes. But both, of course, would be right looking. Another very interesting scenario is the combination of Sentinel-1 together with NISAR because they are left and right looking. So there we could have almost where we have crossing orbits of both at least simultaneous repeat observations every 12 days. And that would be also a quite nice scenario to look at. And then, of course, there's the 8-day acquisition together with SAOCOM, with SAOCOM A and B. Both are launched already, have an 8-day repeat pass, so very, very similar to ROSE-L. And one point I would say what is needed, especially regarding SAOCOM, is to get access to the acquired data, at least in polar regions and mountain regions, in order to exploit the potential of a combined Sentinel-1 and L-band acquisitions, also in preparation of ROSE-L, of course. Are there comments on this and or other ideas?
Well, I jump in on this. I think having ROSE-L and Sentinel-1 occurring at almost the same time is a very good idea. So you get same signal, but at different frequency, and then it actually enhances what you're looking with Sentinel-1. The other point for NISA, I think NISA has a plan already in the pipeline in terms of acquisition, and I don't think there is a way that they change it. But maybe on the other side, when NISA is flying and up, we could imagine then because it's a left-looking mission, it would be very nice to mix with a left-looking mission that exists at ESA to have at least one campaign that covers for example, all Antarctica or all what Sentinel-1 can see or ROSE-L, and the same in Greenland, which is already the case. So we can actually mix all this information to get enhanced product.
So there was a comment from Tazio that the synergy with L-band is more relevant than the very short cases. I don't understand the first notice. Maybe Tazio, you can formulate this. Can you move Tazio to the WebEx. No?
Maybe I can answer for him. I think what he means is that to map faster movements using L-band is the easier approach than going to shorter intervals. Of course, the shorter intervals is the better choice than to have regular intervals between the three satellites. But having L-band is preferred, of course. Maybe ALOS could also be mentioned in the L-band list of satellites. There will also be another L-band.
Okay, yeah, that would be interesting because it already operates, and that's of course interesting then.
Okay, we have to wrap up soon. So any more recommendations from this community about studies, in particular R&D support activities?
I think there should be a kind of activity and R&D how to exploit Sentinel-1, so C-band and L-band closely acquired together for the different applications. So that I think also just to keep in mind that ROSE-L is coming quite soon, so in 5 years, 6 years, or 7 years, and of course we should be prepared once this mission is up. So that would be quite good to start to investigate this.
Yes, so the word on the street is currently that ROSE-L would operate 3 days after a Sentinel-1 acquisition, not a few minutes after. This can of course change, but it's driven by the Copernicus services and their needs. So do we need to study, well, I think we do need to study this kind of configuration as well.
Okay, if not, then I think we close these questions on ice and snow. And okay, thank you for your contributions and
thank you.
And if there is any more questions or recommendation, they can be sent by email later until the end of the week, I guess, to Thomas or myself or Lynn, and then we would try to put them in.
Okay, and the next theme is land cover and vegetation.
I will start for the land cover and vegetation part. Can you move to the next slide, please? So we had 5 presentations and about 20 posters were registered, but I only found about 10 posters really being then there to be seen. And both the presentations and the 20 posters showed that using, in addition to the Sarbax scatter, also the coherence is something which is possible. So it is something which is available. And so for applications, it should be used because it contributes information and it supports both classification and parameter retrieval applications significantly. So that's somehow the summary over many of the presentations and posters shown. The presentations also raised the discussions about the performance of bistatic acquisition. So there were several scientists used TandemX coherence to retrieve parameters such as biomass or to map change in the forest cover. So single pass coherence or this bistatic mode is also of interest in the context of land cover classification and parameter retrieval for vegetation. So the next slide. So I will coordinate the first 2 seed questions and then Javier Duro will do it for the 3rd and 4th seed questions. in many of the contributions, the coherence was used as additional input to classifiers and parameter retrieval schemes, such as random forest or neural networks, deep learning, and so on. So the relation between the radar parameters, so the coherence and the backscatter, and the retrieval parameters, so things like the biomass or the crop type, was primarily done based on statistical methods. Some of the results were, of course, quite convincing, but I still want to ask here a little bit provocative question. Shouldn't the understanding of the signatures of the coherence and the backscatter be improved, and scatter and coherence model should play a more prominent role in these applications? Does anybody like to comment on this view?
So to promote the discussion, so it's clear that recently we have seen improvements when we introduce the INSA coherence as another source of information for the land cover classification and vegetation type of mapping, including also for the crop monitoring. And I think that this is something that must be taken into account, that that is an important tool, and for future missions this may be considered.
I can maybe explain a little bit more what I mean with this question. So in the work presented, quite often it's really the coherence and then the crop map. And somehow I would see as an intermediate step that high coherence over an agricultural area means, for example, bare fields. And if you have the time series of if a field is bare or not, that tells you a lot about the cultivation calendar. And so simply based on this, you have a good chance to guess what crop it is. And so that's the explanation how the retrieval algorithm actually works. But at the moment, it's not really this basic understanding that provides the result, but it's more the training data, and then you have the control group, and you have a certain accuracy that you achieve. And so I could think that the performance could be improved if the understanding would be more part of the retrieval. So maybe as a feedback to Markus's request to suggest also possible topics, maybe along these ideas, some studies from ESA side could also be a benefit to the community, to move a little bit away from just using artificial intelligence between the input and the output, but also consider maybe some coherence or backscatter models on the way between the input and the output.
There is also a comment from...
Exactly, thank you.
Yes, from Kevin. Coherence is dependent on the number of looks used in processing and the neighborhood size in calculating coherence. There could be issue when using ARD from different sensors processing systems.
That raises a question regarding, can that issue be mitigated by doing the coherence by field or using field boundaries? If we're only talking about crops, those are rather simple to generate, but then whether that will work equally well on with different frequencies is debatable. But maybe that be something that can be done for mitigation.
Yes, I think actually there is quite some understanding of what the quality of the estimated coherence is with a certain number of looks, and so moving to polygons, to plots is of course an excellent way to have a really high number of pixels of looks in your estimator. So I think it has to be always under control what the uncertainties in the estimates are, but I think at least for larger fields with current satellites as Sentinel-1, this is quite reasonable quality.
So it's clear that having ancillary information about the parcels, about the initial map of land cover, it could be useful for that. But also we must consider that multi-looking technology and methodologies have been advanced a lot, and we have adaptive multi-looking techniques from several publications recently appearing that give you a more consistent phase estimation in function of the local statistics of a cluster of pixels. So this is also, there has been a lot of improvement in that sense to obtain a more robust coherence.
Okay, I think we can move to the second seed question. So for Sentinel-1, it seems that the 6-day coherence was mostly used and it showed the highest potential. So some mentioned they calculated all different interferograms for their stack over an agricultural area, but in the end they only used primarily the 6-day coherence. And so the initial question is, why is this the case? And then resulting from this is, would even shorter intervals further increase the potential? So we discussed just before what recommendations for a third Sentinel-1 satellite is, where to place it. And so would shorter intervals improve the potential? Would a 1-day interval improve more than let's say 3-4-day intervals? Any opinions from the community on this aspect?
Meanwhile, the questions are arriving. I would like to say that 6 days coherence, when we saw it, was a game changer. So was full of information when we see time series of coherence retrieved by 6 days coherence interferograms. You can see a lot of details. You can really recover the coherence time series very well and see things that at 12 days cannot be retrieved. So it was a game changer having this 6 days coherence in the projects we were participating for land classification.
If I may ask, would the 4 days be a significant improvement or not enough?
My feeling is it would not make a big difference between 6 and 4 days. 1 day is, of course, a bigger difference, especially if you have a little bit denser vegetation. Then with 1 day, something like a forest is still very dense vegetation, very low coherence, and something like maybe a cereal field is then already significantly higher coherence. But it's not completely clear to me what the ideal short interval would be, but definitely I would prefer 1 day over 4 days or 3 days. Maybe other applications could make this decision, and we would be happy with the 1 day, and testing it carefully might show that 3 hours would be nicer, but I think it's not so easy to come up or to succeed with such other suggestions. Maybe this quasi-monostatic or bistatic, where you have a very short interval, that could be quite interesting, but it would be quite something else. And I could imagine it's very difficult to convince the agency to select this mode. So without having confirmed arguments, I would not really support this too much from the vegetation side.
Yeah, I mean, it's not been even on the table. All the options are in the integer days difference with Sentinel-1.
I think there is a comment from Ron Hansen in the audience. So he said that we're not talking about 1 day repeat, but 1, 5, 6 repeat, and this should be compared to 4, 4, 4 repeat, right?
Yes, exactly. That's correct.
I mean, the other point is that when we have, when we have just one chance to have 6 days, if by some chance the data fail, then we go to a gap of 12 or even worse when we are in maneuvers of the satellites and we have two images missing. We are facing a gap of more than 1 month sometimes, and this is a disaster when you are looking at the behavior of temporal time series of coherence of ground formation, whatever. So having the chance to, even if there is missing data, to reduce this gap and not go further of 6 days or 1 week, this is also very, very important to ensure that you will have the temporal evolution of the coherence time series. So in terms of relevancy, this is also very important.
So with the 1 day, 5 day, 6 day cycle, the 2 longer cycles or the 2 6-day cycles ensure somehow the continuity. So you always detect if this bare soil was cultivated, for example, because it decorrelated in a certain period. The 1 day interval is then like a different channel of information. So you don't have this continuously, but you have this every 12 days. You have this 1 day interval, and that's a little bit complementary and different information on the amount of vegetation and the geometry of the vegetation. That's my understanding. Okay, maybe we can move to the third question. I suggest you take over, Javier. Is that fine?
Yeah, considering the current state of the art, so what are the key parameters for Rio data availability that must be considered for regional or country level programs for monitoring initiative? So preparing the wish list for future missions. So for land cover and vegetation observations, what we would require for this type of regional initiatives in terms of resolution, reducing rotary grid paths, availability of polarization channels, and also the ability of multiple wavelengths to have different observations of the same phenomena, right? To retrieve more physical information from different wavelengths. So what could be the priorities? What would be the priorities? To me, as I said, and following the previous discussion, is the reducing the revisiting time and having a lot of data to ensure whatever happens to the satellite, because things happen and we have gaps. So try to avoid large gaps larger than 1 week in whatever the applications. To me, this is something crucial when we focus on regular monitoring programs.
What we could actually also add is the orbit control. So we are now spoiled with getting always these nice short baselines, and that makes the coherence, the 6-day coherence, somehow consistent over time. And so we look at time series. If I look at other satellites or constellations which are being launched at present, I see that this is not something that we get for free. Many of the new operators struggle a lot with getting even repeat paths or then repeat paths with short baselines, and also the data quality. If you have a very high noise equivalent sigma 0, then it also affects the coherence estimation quite a lot. So these aspects are of course also very relevant, and here at least with the orbits we are very much spoiled. Maybe with the noise equivalent sigma 0, it could be significantly better for cross-polarization. So there we cannot exploit the full potential of the coherence at cross-polarization, because for darker areas it is affected quite a bit by the noise.
Yeah.
So the wish list gets even a little bit longer.
So that's why I said we try to prioritize.
Yes, but what you said to have data and to regularly have data, I think is the most important part. And then of course resolution has to be sufficient for the application. And in agriculture, for example, this means a field, and so you need 5 times 5 pixels over this field. Otherwise, it's difficult. That gives a certain, I mean, Sentinel is just good enough.
I think Sentinel 1B demonstrated that the availability of systematic data over different parts of the wall, and the chance of having this stack of data from many years ago. Now we have large stacks of 5 years with continuous data every 12 and now 6 days. Demonstrated that we can see more, we can squeeze more the applications. We can see new things that before we could never imagine with ERS MBSAT, that we have per month, or when we're looking and one image every 3 months, something like this. So and now when you have a gap of 12 days or 24 days, it's a disaster. So you it's like you lose your time series. So I think having data is tremendous value added of this mission, systematic data of every part of the world. If possible, ascending, descending, and with different viewing angles, it's an important issue. I see also very interesting the fact of having multiple wavelengths. So observing the same ground vegetated areas in C-band or L-band could be also very, very interesting for improving classification. That's clear, and that will be also a game changer for future classification applications. So I think we can move on to the last point regarding what is the impact or the level of dependency about the calibration data or other ancillary data to improve or to have a good final accuracy for Landcover mapping. And launch a question. So we could expect to have global results, very good global results without in situ data, without combination with optical data, and having in mind always remote places difficult to achieve in situ, or also places where we are continuously cloud covered in tropical areas, of course. So could we expect to achieve this performance with the new missions and improving methodologies we are seeing?
Yes, I would like to add also, in the interest of saving time, that please propose R&D support activities to ESA and other space agencies. So studies, campaigns, software, platform, whatever you can think.
So as a comment to the fourth SID question, I would say that especially in crop mapping, in the way it is done, often nowadays it depends a lot on the training data, and the algorithm is really optimized for the very local scale, because it uses somehow the crop calendar, the local one, not in a direct way, but indirectly through this training. And this may be different even 20 kilometers away, because it's a little bit a higher elevation, or it's a little bit wetter, or whatever. And so you have very high difficulties to succeed with such an approach in a national or continental or global project. On the other hand, if you understand with land cover mapping, discriminating forest and low vegetation and agriculture and water and urban, we should be able to provide excellent results with the available Sentinel data, for example. So the questions asked and also the method used should be somehow adequate for what you want to do and what you have available.
It's always tricky to extrapolate results from one latitude to another, and we know very well that from remote sensing that local conditions affects a lot the wavelengths, and you may always fine tuning and adapting, as you said, algorithm parameters and play with the data you have. This is always welcome. The question is, there is still large parts of the world without good or very former maps of land cover because of local governments' initiative are not so updated as some other. So this is always an issue when you start a global or regional initiative. Good. So,
any last remarks from the audience?
No answer, I said.
Okay, if there are no last remarks, so then we should move to the last theme of this roundtable technical discussion. So volcanoes, you have 20 minutes and some more if needed.
Okay, perfect. Thanks for hanging in till the end. I'm not going to give a detailed summary of our session. We had 5 presentations spanning caldera unrest to observational studies of recent events, to kind of technical studies using backscatter and summaries of larger projects, and the posters, of which we had 23, spanned a broader array of topics. So what we've tried to do with the seed questions is try and capture some of the themes that came out from everybody's research that was presented at Fringe and that we think might produce some useful discussion. So let's go through them one by one, but please read ahead and have a think if you have a strong opinion about any of the ones we're going to come to shortly, and start putting things in the chat. So the first question that we thought of is quite similar to ones that have been raised by the other communities, which is really how to optimize acquisitions, so how to get the most for our particular application of volcanoes from acquisition strategies. So thinking specifically about Sentinel-1C, I think probably it's fair to say that as a community, we would also like to add to the case for Sentinel-1C being operational and collecting as much data as possible. But in a less than best case scenario, perhaps there's a case to be made for it being activated to respond to volcanic and other types of crisis. you could also treat this as a more general question in terms of how to optimize acquisitions between different satellites. So we're talking about the Sentinels and the commercial SAR missions, Cosmos SkyMed, TerraSAR-X companies, and how to make the most. Because I think one of the things that's special about Volcanoes as an application is that sometimes the processes that we're interested in can be incredibly rapid and sometimes they can be incredibly slow. So we're really interested in a really extensive range of timescales of processes. Does anyone have any thoughts on that topic that they would like to jump in with? So I could have a question for Marcus. If we want to make the case for Sentinel-1C being activated for particular events, how do we make that case?
Well, I mean, the current plan is that it's an in-orbit, 1C should be in-orbit storage, which means that it will have enough activation to be able to do collision maneuver, avoidance maneuvers when necessary, but otherwise systems are off. So the way to affect this is to talk to the Commission and the Copernicus program and try to, from that side, make the case. So if there was enough funding available, then at the higher level of funding, maybe this kind of activations would be possible. But this is a high-level decision in Copernicus.
So I think Roman Hansen asked a similar question in the chat earlier. I guess I'm wondering, do we need a killer science application or a kind of killer applied application, or both?
Well, both. I'd say both. There is the climate 3CS, C3S is the climate service. And there are, of course, services that deal with hazards, and Volcanoes is definitely a hazard. So that's one place. That's the acronym just escapes me, which is the Copernicus service. But I will look it up, and that's one place that you could be contacting.
Thank you. I'm not seeing anything.
So here's one comment from Thomas. So maybe just my experience on this is if we have if several of the different themes are pushing towards a one-day repeat, for example, if this is really helpful for many applications, then of course I think this is a very strong vote to activate 3 satellites in orbit, even if it's probably unsure that we will get it. I think we should make a strong message towards this, that it would be a real game changer for many applications, not only for snow and ice, what I'm representing, but also for many others, what I heard from land surfaces before, and also for volcanoes, there's a need on this. And that, of course, helps definitely if we can push for this and say, okay, that would be a real big advantage to get something like this orbital configuration. Even if the budget is currently against us, but it's still 2 years until the launch of this mission, and there can be big changes in that or in one or the other way.
Correct. So the Copernicus service dealing with hazard is Copernicus EMS, Emergency Management Service. And then, of course, there are other services like dealing with border security might be interested in this. So there are many services that can be contacted to make your points known.
Thank you. So I think that the difference between a 156 configuration and a 444 configuration is a kind of trade-off between consistency in time series and perhaps the serendipity of having a one-day interval over an event that's particularly interesting or exciting, and volcanology having a one-day repeat, which we occasionally get through Cosmos SkyMed, has the X-band obviously would have the advantage of allowing us to perhaps capture processes that we otherwise wouldn't be able to observe. So I think there would be an argument to be made for that for our community. The next question, which I'll move on to, but if anyone has an opinion on the first one, please do interrupt, raise your hand or put something in the chat. The second question, though, is related, so I think it makes sense to move on to it fairly quickly. This is motivated, I guess, from recent experience responding to the Nyiragongo eruption in the Democratic Republic of Congo. So the eruption had started on a Saturday night, and the first two SAR images that spanned the event were acquired by the evening of the Sunday, and they both came from commercial operators, so from Capella Space and from ISI, because they're in a position to take images at relatively short notice, relatively quickly, anywhere in the world. Of course, what you can do with those images is much more limited than what you'd be able to do with Sentinel. You can't make an interferometric time series. There's almost certainly going to be no baseline data. But there is a particular value to having these high resolution backscatter images shortly after an important event. So in this case, for example, they were useful in mapping out a lava flow that had entered the city of Goma, and also in seeing what changes had taken place at the lava lake in Nyiragongo crater. And I think the question for the volcanology community is, how useful are these images? Do we want them? Do we need them? And what's a good strategy for getting hold of them? So you can apply for example, for ISI imagery at the moment through an ESA third-party mission program. And otherwise you have to have quite a big budget or try and work through an established relationship with someone at the company. But at the end of the day, these are kind of commercial operations, and they're aiming to raise funds. So getting the data for hazard assessment and for research is more challenging. So it would be good to know if there are any opinions in the community about the right strategy for dealing with this, and whether people consider these data sets important. I think because we're running a little bit late and perhaps there aren't huge numbers of Volcano people who are kind of logged into this, what I might do is also email around some kind of community mailing lists for feedback for Friday. And if anyone would like to write me an email with an opinion about any of these questions or anything else that you think we should be discussing, please do that. But if there's nothing on that question, I'll move on. Okay, and the next point, it was something that came out of several of the...
I think someone raised, Philip raised his hand.
Do you hear me? Yeah? Okay.
Yep.
Often we can see that the problem is related to the charter. In fact, as far as you have human beings at risk, you can get maybe the data through the charter, and it's a recurrent problem since the charter exists, in fact, and often we have the same you say needs for interferometry or very close acquisitions, and we need very nice data with resolution, etc. So it can be related somewhere to the charter and get free data through this way.
Yeah, I think you're right as well, particularly that one of the challenges we've often had with the charter data is that the SLCs aren't released, so what you can do with the imagery is a little bit more limited. But perhaps for these high resolution images that wouldn't be suitable for that sort of analysis anyway, that doesn't matter that much. So maybe the case to make is to encourage these companies to engage with the charter.
Yeah.
Thank you. Okay, moving on to the next point. Several of the posters and a couple of the presentations touched on this, but some of the posters particularly talked about automated INSAR processing, and there are lots of different groups working on this. And many of them are working for kind of broader applications, so on-demand processing, for which can be for lots of different purposes, large-scale automated processing, primarily for tectonics. And I think there's an interesting question for us as a group of how we can design automated INSAR processing, particularly for volcanoes, and particularly for machine learning and detection of volcanic signals. Are there things that we should think about in the way that we deal with particularly the large, open, freely available SAR datasets to produce the best possible product for detection of volcanic signals? So, for example, that might incorporate things like the pixel size for the processing. It might involve choices such as which pairs of images should be used to construct interferograms, whether you should be looking to make the shortest possible pairs or incorporate larger temporal baselines. Are there particular issues in our community as to how we're using or should be designing automatic processing products?
Let me add some comments here from an INSAR point of view. I think one of the key points for automatizing INSAR processing in volcanoes areas is the compensation of the atmospheric perturbations, especially of the troposphere. So usually volcanoes are on mountains or mountainous regions where troposphere and atmospheric perturbations is quite important signal. And usually there is a high correlation of this type of perturbation with a large K type of deformation signal you are looking for. So the key for automatizing this processing, apart from deciding the pixel size and the temporal baseline to catch the non-linearities of the fluctuation of the area, is the proper compensation of the atmosphere through usually external models. So I think this should be one of the key points.
Thank you. I think there was a question in the chat. Are the volcanic eruptions and monitoring So I think it's about the relationship between different hazards and multi-hazards. And I think it's probably correct that there are some similarities in the way that you might want to process large volumes of imagery to look at volcanic signals in the way that you would for landslides, in that they're similar hazards and that we are likely to know where they are in the large established landslides. And also the spatial resolution of the final deformation map matters a lot to getting information out at the level that you need to do some modeling. So I think in that respect, there's a similarity. Are there any other comments from the participants? If not, I'm going to move on to the last couple of questions. So this penultimate one is how best we can coordinate tasking for volcanic events. And this is essentially trying to make sure that the most appropriate imagery are acquired without kind of conflicts in image tasking. This isn't something that is likely to happen with Sentinel, but it can do, for example, with tasking TerraSAR-X imagery or with Cosmos SkyMed, particularly where we have volcanoes that are located next to other hazards in particular that people want to monitor. So, I mean, there are various ways that people try to do this. A lot of them a little bit probably informal and relying on to some extent kind of personal networks and knowing where in the world other groups are working and which volcano observatories are have a responsibility for monitoring. If people have suggestions as to how we could be doing this better, I think that would be really great to hear.
So if I understood correctly, there's presently no international coordination for this. Like the polar people have this Polar Space Task Force, which is where they discuss how to coordinate observations. So is this the case for the volcanologists, that such a thing doesn't exist?
I would say that as a kind of incipient version, the polar community is kind of, I guess, the model for, I think, where we would like to be. At the moment, we have a couple of projects. So one is the CEOS Volcano Demonstrator project, which I'm involved in, which aims to coordinate tasking, but we don't operate globally. Right? It's a demonstrator. It's done as kind of on a best efforts basis by a group of people who are interested in it. But it only at the moment operates in 3 parts of the world, in Latin America, Africa, and Southeast Asia. And I think the hope is that eventually this will kind of demonstrate the need for international tasking, internationally coordinated tasking, and have the potential to be expanded into something similar to the Polar Task Force, but we're definitely not at the same stage yet.
There is also a comment from Pablo Gonzalez, and he says that any automatic processing system should also consider to update digital elevation models. Therefore, looking for synergies with other sensors or missions is essential.
Yeah, and I think that's a really good point, because one of the byproducts of producing interferograms over areas where the digital elevation model you're using is not up to date is, of course, a correction to the topography, which is something that is potentially also useful in volcanology to detect topography that changes in response to volcanic eruptions. It's a good point. Thank you, Pablo.
There is also a question from Mark Bemelmans. The question is, LIXPAS, which processes at the 100-meter resolution, even for volcanic targets. If possible, this resolution should be increased, as the formation signals can currently be missed due to poor resolution. Could this be implemented effectively?
So I think the answer to that one is yes, but it hasn't been done yet. I know one of the things talking about LIXPAS specifically, one of the plans for development was coming up with tailored processing for volcanology, but it's not something that's been implemented yet. It is in development, but it would require having a divergent processing stream for the tectonic applications from the volcanic ones, which obviously kind of increases the effort involved. But if you think about the total area of the Earth's surface, which is relevant looking for about volcanic deformation signals, it's relatively small compared to that covered in ice, or that where you might have tectonically interesting displacements. So I think of all of the applications, it should be relatively achievable. I think what we could do is possibly leave the last question for a kind of offline discussion, because it's less related to the SAR data itself, but to synergies between the SAR and INSAR and other data sets. If anyone would like to respond to it, the question is, what data and models do we need to link particularly non-eruptive deformation? And this is thinking about some of the talks that were presented today. So the one looking at Demullo and also Tal, the presenters there made the point that the interpretation is very much aided by looking at, for example, ground-based monitoring networks and also thermal measurements. And I think there's a broad question for our community of which are the most important data sets that should be acquired in tandem with SAR imagery in order to make the best analyses that we can. If anyone would like to feedback on that now, that would be great. But otherwise, please put your thoughts in an email or get in touch, and we'll incorporate it into the summary for Friday.
I would like to also remind everybody that you can connect with Susanna and all the other speakers' chairs through Brella platform. There is an option for networking, and you can even ask for a one-to-one meeting with the speakers. So this would be also an occasion to express your opinions. There's one more question from Farhan Khalid. In comparison with which remote sensing technology provides more precise and accurate results in volcanic monitoring till now? Is it LiDAR or radar?
I think it depends what application that you're talking about, but I think INSAR is probably much more widely used than LiDAR measurements. I mean, there have certainly been kind of repeat LiDAR measurements made over lava flows and some volcanoes with changing topography, which provides accurate measurements of topographic change. But that can, of course, also be achieved by using a bistatic radar, in particular Tandem X and co-SSEs. But if the person asking the question wants to discuss that anymore, we could do that offline. Yeah, if any of the other volcanologists listening have any feedback or comments, please do email them. Thank you for everyone who did contribute.
Yes, it looks like that we are approaching the end of this technical session. So thanks to all the panelists and all the attendees. And well, I'm looking forward to the wrap up of these three sessions in the session summary on Friday. So goodbye with these themes until then. And I can only say that in the next Fringe, we would close the workshop here, but there would be still tons of SAR stuff to discuss after the last session. So hope to see everybody in person next time. All right. Thanks. Bye.
Thank you, everybody.
Thank you.
Thank you.
Thank you all.
Thank you all.
Yeah, thanks for the technical support.
I just want to say, maybe if you have any particular comments that came up during this technical session, apart from the slides that you sent or the comments that you sent, you can also send it to us. So we will integrate it further in the big recommendation document.
Thomas, you're muted.
Sorry. So how long will be the presentation on Friday for the summary for each of the topics?
It should be 10. It should be 10 minutes. Okay. Yeah, 10, 12, something like that. Of course, you can put a lot. Of course, you can put a lot of text on the slides for so as inputs to Isa, but the presentation can't take super long.
Yeah. Okay. No, 10 minutes. That's fine. Okay. Perfect. Okay, then have a nice beer.
Cheers to everybody.
Cheers to everybody. Thanks.
Bye.
Thank you. Bye-bye.
Okay, bye-bye.
Bye-bye.